In this slide, we talk about power set of a set. Now, power set of a given set is nothing but set of all subsets of that set. Now, that is quite a mouthful to say, so let us write it down with an example. So, given a set as A comma B, we want to determine the power set of this set. So the power set of this set is set of all subsets of set S. So let us write down what I have just said. So power set is set of all subsets of this given set S. So let us write this down. So power set of S is, so obviously null set is subset of every set, element A is subset of S, element B is a subset of S, and AB is a subset of S. So this is how we get the power set of S. So notice that if we count the number of elements in set S, we have just 2 elements. So let us write down NS means number of elements in set S. So number of elements in set S. And you count down the number of elements in set PS, you see there are 4 of them. Yeah, there is a null set, set A and set B and set AB. So this you can write as 2 squared, 2 to the power of 2. Now this exponent 2, you raise to the power 2, this is same as this number, that is number of elements in the original set S. So if you have number of elements in set S as K, then the number of elements in set PS would be 2 to the power of K. So if we have number of elements in set S as K, then number of elements in PS would be 2 to the power of K. Now let's start with an example. Okay, set S is, say given us another set 1, 2, 3. So number of elements in set S is 3. So number of elements in the power set of S will be 2 raised to the power of 3. That will be 8. Yeah. So this will be 2 raised to the power of 3. This is 8. So let us write down all the elements. So power set of S consists of the null set 1, 2, then 3. We have another sets like 1, 2, 2, 3, 1, 3, and then 1, 2, 3. Yeah, the entire set itself. So you can count now the number of elements of this set, and there are precisely 8 of them. Null set 1, 2, 3, 4, 5, 6, 7, 8. Further examples. If S is a null set, then power set of S we have to determine. So number of elements in this set is just 1. So power set of S consists of 2 raised to the power of 1, just 2 elements. So notice how we write the power set. The power set is also null set, but we have elements written like this. Yeah, so notice how am I writing this. Yeah, so this is important to notice. It's kind of a convention. Now we talk about universal set. Now sometimes we want to fix a set, fix a big set, and study relationship between subsets of this set. Yeah, for example, you could fix a big set like all the people of the world. So let us write down what I have just said. So sometimes we study relationships between subsets of a big set, and you fix this big set. This big set is called the universal set U. So we fix the big set and call this the universal set U. So it is denoted by U. For example, set of all the people in the world. So subsets of this could be like I, set of people in India, and G, say set of people in Germany. And we want to study relationship between, say, set of people in India and set of people in Germany. So I is set of people in India and G is set of people in Germany. Okay, now we have talked about now power sets and universal sets. Now we want to talk about Venn diagrams. Now Venn diagrams were first made by English logician or mathematician John Venn, and they are very good at describing the sets visually. So you can see what the diagrams are. We have already used these Venn diagrams in describing how subsets look like in one of the previous slides. So let us write down about Venn diagrams. So Venn diagrams, these are named after English logician John Venn. And we will describe Venn diagrams with the help of 3 examples. So the first example is very simple. You fix a universal set U as containing numbers 1, 2, 3, 4, 5. And we have a subset A of this universal set consisting of elements 2 and 5. So now let us draw the Venn diagram. So you first draw the universal set U, and then you draw the set A inside the universal set. So let us write down the elements. So A contains element 2 and 5. So that is why we will write 2, 5 inside the oval made out of the oval which represents set A. So we have 2, 5 in A and 3, 4 outside. So another example, U consists of elements A, B, C, D and E. And there are 3 sets. S1 is A comma B, S2 is C comma D and S3 is just B. S3 is equal to B. Now we draw the Venn diagram. So you first draw the rectangle corresponding to the universal set U. And we have couple of circles inside it. Yeah, we have to draw 3 circles, one for S1, one for S2 and one for S3. And obviously S3 is contained in S1 and S1, S2, S3 are all contained in U. So first I am writing S2, you have C and D. Then I will draw, this is big circle is S1, S3 is a subset of S1, so you draw it inside S3. S3 contains element B and S1 contains element A and B both. Yeah, but A is not contained in S3, so I am drawing it outside the circle S3. And the element E, which is not contained, which is an element of U, but it is not contained in S1, S2 or S3, and it is drawn outside. So number 3. So U is the universal set of all people in the world. And we will have 2 sets, I as citizens of India and G as citizens of Germany. Now since Government of India does not allow dual citizenship, so you can only have distinct sets, that citizens of India are disjoint from citizens of Germany. So some countries of the world allow dual citizenship. For example, US allows you to have citizenship of as many countries as you want to, but India does not allow dual citizenship. So you can see now that if we have 2 sets, citizens of India and citizens of any country of the world, those 2 sets would be disjoint. Now let us draw this picture of 2 disjoint sets. So we have this universal set U, and we have 2 sets in it, I is citizens of India and G is citizens of Germany. And these 2 sets are disjoint, as you can see. So in this slide we talked about power set, we talked about universal set, and we talked about Venn diagrams.